Lesson 3-8 is apply rational numbers. So make sure you label your notes. Here we have the intro, which says that the order of operations is used to simplify numerical expressions with whole numbers. Those rules, those order of operations, it also applies to simplifying numerical expressions with rational numbers. So for example 1, we want to apply those rational numbers operations. And remember, evaluate means to substitute and simplify. That means you're going to put a number in for a variable, and then you're going to use your order of operations to simplify. Okay? So the first example says evaluate A plus B times C plus D if A is equal to negative 3.6, B is equal to 2 4/5, C is equal to negative 1/2, and D is equal to 6 3/4. So wherever there's an A, we're going to put in negative 3.6. Wherever there's a B, we'll put 2 4/5. Wherever there's a C, we're going to put in negative 1/2. And wherever there's a D, we're going to put 6 3/4. So we're going to put this A in there for A. We're going to put this B right there for B. We'll put this C right there. And we'll put this D right there. Okay? So let's do it. So A is equal to negative 3.6. So we've got a negative 3.6 plus B, which is 2 4/5, times C, which is a negative 1/2, and D, so we're going to put plus D, which is a 6 3/4. Okay? Now, remember, we want to have apples and apples, oranges and oranges. So here we want to have either all fractions or all decimals. Okay? And if you test out using your calculator to see if you have any repeating decimals, that will help you decide. So let's test it out. So we've got 4/5 in there, so we can divide 4 divided by 5, terminating, good. 1/2, we know that's terminating. And of course, 3 divided by 4, that gives us a 0.75. So these are all terminating when we change them to decimals. So why don't we just change all of these terms to decimals, okay? So we've got a negative, and I'm going to rewrite. So this is equal to a negative 3.6 plus 2 that's going to give me a 2.8 times a negative 0.5 plus a 6.75. And now we have all decimals. And now we use our order of operations. You remember your PEMDAS. That means grouping symbols, exponents, multiplication and division from left to right, and addition and subtraction from left to right. Now, these parentheses, those are not grouping symbols. That means multiplication. So, in this case, we're going to do this multiplication first. And of course, you can use your calculator, and we will rewrite. So we've got a negative 3.6 plus, now we're going to put this in the calculator. So that's 2.8 times 0.5. That gives us 1.4. But remember, this is a positive times a negative, so this is going to be a negative. So we have plus a negative 1.4. negative plus a negative 1.4. Okay, and then finish it up. So we have plus 6.75. And now we can use our calculator to help us with this. So we're going to first, and again, it's addition and subtraction from left to right. Or we can put our negatives together. Okay, so in this case, it's either way. We're putting those two together or we're doing left and right. That's the same thing. So here we've got a negative 3.6 plus a negative 1.4. Negative plus a negative is going to give me a negative. And then we'll put, if you need it, 3.6 plus 1.4. We add the digits. So that's going to give us a 5. So this is negative 5 plus 6.75. All right, so now we have a negative plus a positive. That means we want to subtract the digits and take the sign of the bigger number. So when we subtract those digits, we get 1.75. And if you need to put it in your calculator, that's fine, but that's minus 5 here. So this is going to be a 1.75. And the bigger number is 6.75, so it's going to be a positive. So this is a positive 1.75. Now, if we want to change this back to a fraction, we know that 1.75 says 1 and 75 hundredths. So here, we want to rewrite this is equal to 1 and 75 hundredths. And of course, we can simplify 75 hundredths by dividing by 25. And that gives us 1 and 3/4. Okay? And of course, 0.75 is one that you should know that is 3/4. All right, so now that you have that example done with me, why don't you press pause and try to do example B on your own. And then you can start the video again and see the solution. All right, so for this one, we're going to substitute A, B, and D. So here we've got A is 3/4. So we're going to put 3/4 in there, 3/4, plus B, which is a negative 1.55, minus D, so that's minus a negative 1/4. Did you guys catch that? Okay, so that minus a negative, we're going to do plus a positive. We're going to keep change over there. So why don't we just go ahead and change these to decimals, because you can see that 3/4 is 0.75 and 1/4 is 0.25. So let's go ahead and change those. So this is going to be 0.75 plus a negative 1.55 minus a negative 0.25. Sorry about that. 0.25. All right. So now, let's clean this up a bit. So we want to do keep, change right there. So we're going to use our colors, keep, change. And now we have positive, negative, positive. So if you want to, you can just combine all of your positives together. So we can combine this one and combine that one. So we can say 0.75 plus 0.25, well, of course, that is equal to 1.00. So I can just write 1, okay? So that is equal to 1. And then bring down the rest of it. So this is plus a negative 1.55. And now we subtract the digits and take the sign of the bigger number. So here, when we subtract, you can see you're going to get a 0.55. So this is going to be a 0.55. And then that bigger number is going to be the 1.55, so this is going to be a negative. And that's your final answer. All right, so let's go ahead and move on to example 2. So example 2 is apply rational number operations, just like the first one, but this time it includes the absolute value. Now remember, you guys, absolute value, let's do a little sidebar here. Absolute value looks like that, and absolute value is always positive. Always positive. Because absolute value is the distance a number is away from 0 on the number line. And a distance is always positive. That's why it is always positive. Okay? And so, as a little example here, just a sidebar, here if I had the absolute value of 4, well, that's 4 units away from 0 on the number line. So that's going to be equal 4. The absolute value of 4 is 4. If I have the absolute value of -4, well, -4 is also 4 units away from 0 on the number line. So that's also going to be 4. So -4 over here, -4 over here is 1, 2, 3, 4 units away from 0. And over here, +4 is 1, 2, 3, 4 units away from 0 on the number line. So you can see both of their absolute values, both of their distances from 0 on the number line is 4. Okay, so after that little review of absolute value, we can move on to the example. So here we have the absolute value of x. Let's fill that in. We've got the absolute value of x, and x is -2.6. So we're going to write the problem. So we've got absolute value of -2.6 plus y, which is -1/2, times 0.4 plus z, so plus z, and that's a negative, so plus a -5/8, close my parentheses, and that's it. Okay, so that's our problem. So now we can simplify this, okay? Again, you can check your decimals. So 5/8, 5 divided by 8, that gives us a terminating decimal, and we know that 1/2 is going to be 0.5. So we can go ahead and change all of these to decimals. So here we've got the absolute value of -2.6 plus -0.5 times 0.4 plus a -5.8. All right, so a -5.8 is a -6.25, 0.625. So plus a -0.625. Okay, and close parentheses. Now, you guys, I just want to point out that this parenthesis goes with that one, and this parenthesis goes with that one, and that's what's going on there. So, using our order of operations, we can do this absolute value, and we can do this addition right here first. Okay, so the absolute value of -2.6 is +2.6. So this is going to be 2.6 plus a a negative 0.5, just bring that down. And then over here, we've got a negative we have a 0.4 plus a negative 0.625. Now, different signs, we want to subtract the digits. Now, when we subtract, we want to, if you want to know which one is bigger, you have to annex some zeros here. So that's 0.00. So you can see that 625 is greater than 400. Okay, 625 is greater than 400. So we know that 625 is the greater digit. So we're going to subtract 0.625 minus 0.4, and that gives us 0.225. And the bigger digit is negative, so this is going to be a negative 0.225. All right, now with our order of operations, we're going to do the multiplication next. So a negative times a negative is a positive. And you can just put that in the calculator. So 0.5 times 0.225, that's going to give us 0.1125. 0.1125, and it's going to be positive. So we've got 2.6 plus positive, what was that again? 1125. 0.1125. And now we finish this by adding. So we've got 0.1125 plus 2.6, and that gives us 2.7125. 2.7125. And I'm okay with you guys leaving this as a decimal. All right, so why don't you stop the video and try example B, example 2B on your own. Stop the video and then restart it when you're finished to see the solution, okay? All right, so before we start this, we can see that we're going to have some repeating decimals. So here, if I divide 5 divided by 6, 5 divided by 6, that's going to give us a repeating decimal. And if I divide 1/3, you know, that's going to give us a repeating decimal too. 1 divided by 3, that's going to give us a repeating decimal too. So that means we need to use fractions to simplify this expression. So let's rewrite. So we've got x, so that's a negative 5/6 plus 0.3. We're evaluating, so we have to substitute first. Negative 3, and then we've got the absolute value of y. So that's going to be the absolute value of negative 1/3 minus z, which is 3/4. Okay, very good. So now we can see that we can simplify that absolute value first. So let's go ahead and do that. So that's, I'm going to rewrite negative 5/6 plus, I'm going to rewrite the 3/10, the 0.3 as 3/10. So that's 3/10. And then we've got the absolute value of a negative 1/3 is a positive 1/3 minus 3/4. Okay. Now, now we're going to complete the grouping symbols. So inside the grouping symbols, we've got this. Now, before we subtract that, we need to get common denominators. You know what? Why don't we get common denominators with, well, let's just do the 3/4 and the 3/12. The 1/3 and the 3/4. So what the common denominator with 3 and 4 is 12. So here we want to multiply times 4 here and times 4 here. And then we want to multiply times 3 here and times 3 there. So let's rewrite. So this is -5/6 plus 3/10, and all we're doing is rewriting, okay? And then we're going to rewrite this part right here with common denominators. So that's going to be 4/12 minus 9/12. And now you can see that this is what we need to simplify. So 4/12 minus 9/12. Remember, if we do keep, change, that's going to give us a -5/12. Okay? So let's rewrite. -5/6 plus 3/10. And now this is going to give us a -5/12. Okay? So here we got our common denominators. And then down here, now, before we multiply, this part right here, we should simplify. Okay? So let's see. We can simplify. Let me move this. Let me delete the highlight. So we can simplify with the 3 and the 12. So 3 divided by 3 is 1. And 12 divided by 3 is 4. And we can also simplify with the 5 and the 10. So 5 divided by 5 is 1. And 10 divided by, oops, let me write that in for you. 5 divided by 5 is 1. And 10 divided by 5 is 2. And now we can multiply straight across. Now you know, again, that a positive, let's see, let me highlight this. A positive times a negative is a negative. So when we multiply, we're going to write negative. So here, rewrite again. So we have -5/6 plus, and when we multiply straight across, this is going to be plus a negative. This is going to be 1 times 1 is 1 over 2 times 4 is 8. And now here, before we add, we need to get our common denominators. So with 6 and 8, the common denominator is 24. I think it's 24. Yep, 24. So here we can multiply times 4 here, times 4 there, and we can multiply over here times 3, times 3. So we rewrite again. So this is going to give us -20 24 plus a -3 24. And now we have a negative plus a negative. So same sign, our negative plus a negative, that's apples plus apples. We're going to get apples. So we're going to get a negative. So when you have a negative plus a negative, that gives us a negative. And now we just add the numbers. So 20 plus 3 is 23, and the denominator stays the same. So we have 23/24. All right, so for example 3, the word problem, we are still applying rational numbers. Now, I do want to point out to you that this one is going to be solving an equation. So far, we have been simplifying equations, but I do know that in 6th grade, we talked about solving equations. So we're going to go ahead and do this one, okay? So it says, Rosie is driving from Knoxville, Tennessee to Orlando, Florida. She drives 317.88 miles before stopping for lunch and then drives another 203 and 4/5 miles before taking a break. Rosie has driven 4/5 of the entire trip. How many total miles is her trip? Phew! So we've got 4/5. That changes to a terminating decimal, so we can use decimals in this problem. All right? But we're going to start out rewriting or starting to write the whole problem. So let's highlight our important information. So let's see. We've got so she drives 317.88 miles before stopping for lunch, and then she drives another 203 and 4/5 miles before taking a break. Now, it says Rosie has driven 4/5 of her entire trip. So that means, you guys, this, when we put these two things together, that's it. That's 4/5 of the, I'm sorry, that's 4/5 of the entire trip. Okay? What does of in math mean? That means multiply. So that means if we multiply 4/5 times the entire trip, which we don't know what it is, question mark, we don't know what the entire trip is, so that's times x, we can write it just x. So x is the entire trip, times x, that's going to be what she's already driven. So that's going to be the 317.88 plus the 203 and 4/5. Is everyone with me? Okay. So now we can simplify this. So I want to write 4/5 as a decimal. So 4 divided by 5 is 0.8, okay? So let's rewrite it. So here's our new expression and equation, and now I'm going to add those together. So that is, oops, where's my calculator? All right. So here we have 317.88 plus 203.8, and that's going to give us 521.68. So 521.68. Now on this side, we've already said that this 4/5 is equal to 0.8. So we've got 0.8 times x is equal to 521.68. So now, because this says 8/10 times x, the inverse operation is division. So we just, in order to get the x by itself, remember the cover up I taught you? Cover up the x. To get that x by itself, we want to get rid of the 0.8, the 8/10. So that's what we're going to divide by. So we're going to divide by 0.8 on both sides. And anything divided by itself is equal to 1. And 1 times x is x. So on this side, we have x. Now on the other side, we just use our calculator. So that's 521.68 divided by 8/10, and that gives us 652.1. So 652.1 miles. This is the amount of the entire trip. All right, very good.